right, we're moving on to exponents today, and with this lesson, we're going to talk about all the exponent rules. That's what all of these are, and then we're going to practice. So we have examples on both sides, so they'll have us practice the rules, okay? So the first thing is when we have two variables that have exponents and we multiply these together, so this is our multiplication rule. What this means is I have 3 x's, so that would be these first 3. And then this says I have 2 x's, which would be these 2. And if you multiply all of these together, you get x to the 5th. So what our rule looks like is when we're multiplying and we have the same base, we add the exponents. Okay? Now here we're dividing. So this is the same as saying 1, 2, 3, 4, 5 divided by 1, 2. And if we look at canceling things out, this cancels with this, and this cancels with this, and what we're left with is x cubed. We have 3 that are left, so we're left with x cubed. So what this rule looks like is x to the m divided by x to the n is x to the m minus n. And the order matters. It's always going to be top minus bottom. Okay? Now this one is different. This is not multiplying. What this is saying is that we have 3 of the x squareds. So I have an x squared, and I have an x squared, and I have an x squared. And now what's happening is we're multiplying. So if you go back up here and you look at this multiplying, remember when we're multiplying we add. So if we add these up, we have 2, 4, 6. So this would be, hold on, keep with my pencil here. This would be x to the 6th. So what's our shortcut on this? This is if we have x to the m, and this is to a power, right? So this is to a power. I have x to the m times n. So we're going to actually multiply. So in this case, I would have 3 times 2, which is 6. Okay? Now with this one, we have our exponent on the outside. So what it's like saying we have 3 x's and we have 3 y's. So we're going to write this as x cubed, y cubed. So when we have an exponent on the outside, it goes to everything. I have 2 variables. Here I only had 1 variable, so we would take it just to this power. Now this works exactly the same way if we're dividing. The 2 goes to the top number and the 2 goes to the bottom number. So with this one, I'm going to have x squared over y squared. Okay, now these are really important, and these are going to be our negative exponent rules. So when we have an exponent rule, what we want to do is we think about this. Negative exponent means we move it. All right? So here's the important part. Don't make anything negative. All right, so let's look at this. This is x to the negative 2. I have a negative exponent, so I'm going to move it. So it becomes 1 over x squared. Don't make anything negative. So this negative, all it means is move, so it moved to the denominator and it became positive. With this one, it's in the denominator already, so the negative exponent means move. So this one becomes x squared. We take this negative exponent, we move it, so we're going to move it from the denominator to the numerator, and it becomes positive. Okay? And then this is our last one. So our last one, if we have this, x squared over x squared, this is the same as 1. So this would simplify to just 1. And if this simplifies to 1, then we're going to say anything with this, we don't have an exponent power anymore. So what's happened is if I look at this with my division rule, which was clear up here, we say that we subtract our exponents. So that's the same as saying x2 minus 2, which would be x to the 0 power. Well, we just said that if this, using our exponent rule, is x to the 0 power, but this simplified equals 1, then what this means is x to the 0 power equals 1. And our rule here is anything to the 0 power equals 1. That's our rule. Okay, now some of these are super easy to see. Like with this one, we have a to the 3 over a to the 7. Now, I'm going to show this two different ways, okay? I'm going to show you what I think is the easier way to think about this. So, if we look at this strictly with our rule, we're going to say a cubed minus 7, top minus bottom, and this would be a to the negative 4. And when we have a negative exponent, that means we move it. So this becomes 1 over a to the 4, and that's my final answer. But sometimes you don't have to do all that work. And here's what I want you to think about. This tells me I have 3 a's on the top, and this tells me I have 7 a's on the bottom. So I have more a's on the bottom. How many more? 4 more, right? So this is the same as 1 over a to the 4, right? 3 on the top, 7 on the bottom. I have more on the bottom, 4 more on the bottom, so I'm going to keep that on the bottom. Now, mathematically, this is how this works out, but if you can just look at this and logic through it, you get the same answer, okay? So just think about it like that. Now with this one, because I have a negative exponent, the exponent is going to go to everything. So I'm going to have 2 to the negative 3 over 5 to the negative 3, right? Exponent goes to the top, exponent goes to the bottom. Negative exponent means that it's going to move. So if it moves, then this becomes 5 cubed on the top because it became positive, and this moves to the bottom. So that's 2 cubed on the bottom. All right, another one with a negative exponent. So here I have just x on the top. Well, because I have x on the top, nothing's changing. It's not combining, I can't do anything. So the x is going to stay, but the negative exponent needs to move out of the denominator. So I have xy squared. There's no more denominator. So remember, the only thing that moves has the negative exponent. So this x is just chilling. It's just hanging out, okay? Now, here I have the exponent on the outside. So the exponent goes to everything on the inside. So we would say 3 to the 4th power, and then x to the negative 8th power. Remember, when we have an exponent to an exponent, we multiply. So this is like saying 3 to the 1. So if I multiply 1 and 4, I get 4. So here, I've got to move this guy. It's negative. It's going to go in the denominator. And 3 to the 4th power is 81. So 81 over x to the 8th. So that's what that looks like. Okay. And just like this one, you should know 1 through 20. You should know all of these squared, and you should know 1 through 6 cubed, and you should know 1 through 5 to the 4th power. So know these different powers. So if you see something like this, 3 to the 4th power, you should know that that's 81. Okay? All right, let's flip it over. All right, so they're going to get a little more complicated. We've got other things going on now. So we want to simplify these as much as we can. So I'm going to do this one first. So this becomes x to the 6th, and multiply times x to the 5th. When I multiply and they have the same base, then I'm going to add the exponents. This becomes x to the 11th. Okay? So here, with this one, I'm going to take this 3, and it goes to everything on the inside. So this gives me 3 cubed, x to the 6th, times 2, times x to the 5th. Okay? So 3 cubed, 3 times 3 is 9, 9 times 3 is 27. So this is 27 times 2, if I just move this 2 over. And then I have x to the 6th, x to the 5th. So this becomes x to the 11th. When I multiply this out, I get 54 x to the 11th. Okay. Let's skip 7. You can come back and do 7. Let's do 8. So I've got this negative 2 on the outside, but this negative 2 is going to go to everything on the inside. So if I have negative 1 and negative 2, I have x squared. A negative times a negative is a positive. And then I have y to the negative 2. And this becomes z to the negative 4. So I have z squared times negative 2. So if we look at this, this is negative and this is negative. So those two things have to move. And so when these two things move, I end up with x squared. Y squared moves to the bottom now. And you notice when it moves to the bottom, it becomes positive. And z to the 4th moves to the top. And when it moved to the top, it became positive. I'm going to let you do 9. Let's talk about 10. So we've got a couple things going on with 10. So the first thing that I'm going to do, and this is a really good strategy, is I want to move all the negatives first. So if I move all the negatives first, which means I'm going to make everything positive, that's what I'm going to have. So I'm going to have x to the 5th. This y squared goes to the bottom and becomes positive. This x moves to the top and becomes positive. And this y also moves to the top and becomes positive. So this is what it looks like after I make everything positive. All right, so now I'm going to combine. So I have two bases of x here. So I'm multiplying. When I multiply, I add my exponents. And this tells me I have 3 y's on the top, 2 y's on the bottom. I have more on the top. I have 1 more on the top. So that's what that looks like. Okay? All right, let's do number 11 together, because number 11 is probably the most frequently missed type of question. Now, what this is saying that I have x plus y to the 8th and x plus y to the negative 8th. So let me make this positive first. So what I have when I do this is I have x plus y to the 8th, and now all of this is moving. So I have x plus y to the 8th again. So these are the same base. They're both x plus y. And so what I end up with here, since they're the same base, I'm going to add my exponents because I'm multiplying. So I end up with x plus y, the whole thing to the 16th power, and that's my answer. Now, the most common thing that happens here is that it is not, and I'm going to write not in red here, it's not x to the 8th plus y to the 8th. It's very different than if I had this, x, y to the 8th. This one has an operation. So this does not work. This becomes x8, y8, because I'm distributing that 8 into both of these. This one, x plus y to the 8th, this is actually a FOIL problem, because what I have is x plus y, x plus y, x plus y, and I have that 8 times. And so there's a big difference between one where we have an operation on the middle and one where we don't have an operation in the middle. So super important. Okay, let's look at 12, and then I'll get you to go back and do 7 and 9. So I've got a whole bunch of negatives in here. So what I want to do is I want to just distribute this and then re-look at everything. So when I do this, remember this is going to every term on the inside, and that gives me a to the 10th, b to the 15th, c to the 20, and on the bottom I have a to the 10, b to the 15, c to the 20. So this gets distributed here. On the top I have a negative times a negative, so this is what I have. So I have an a and an a, so this cancels out, this cancels out, this cancels out, and so the whole thing simplifies to just 1. Okay? All right, I'm going to pause my video, and I want you to go in and do 7 and 9, and then I'll show you the correct answers on here. Okay, I tried to use this purple marker, but it didn't work very well. So I distribute this through. Here's what I have. If you get jammed up on 5 to the 4th, this is the same as 5 squared times 5 squared. So this is the same as 25 times 25, which is 625. So that's what this simplifies to. With this one, I distribute everything out, and then I move it to make it positive, and you end up with y to the 6th, x to the 4th, and then I have 3 squared and 4 squared, so 9 times 16, which is 144. All right, good luck.